Right. Oh, this is too slow. Yeah, sorry. Just having lots of problems today. So all about the Raspberry Pi. So I thought we should have a bit of a run through of some very basic things about the Raspberry Pi, and maybe everyone can sort of chip in their own experiences. So obviously released on the 29th of February 2012. So our favorite single board computer. So originally it was indicated intended for education, which is still very much a big part of the Raspberry Pi. So there's Raspberry Pi Foundation, which does the sort of like the education piece. There's Raspberry Pi Trading Company that builds the Pis. So it's a little Linux-based computer. I know most of you guys, everyone knows this, and this has sold millions. So the last number I saw was sort of 60 million sold. So this is now the highest selling British computer in history, outselling all the other ones, BBC Micro, etc. So obviously here, let's see from here, we've got a huge enthusiastic community, some of which have actually made it online and some actually which didn't give up on me. So thanks for not giving up on me. Right. I thought I'd run through some of the portfolio and I'll skip a bunch of the older models because I didn't want to spend all day doing that. So one of the most important ones you can buy now when you should consider buying is the Pi 02W. So this is for anyone that has a Pi 3B plus, it's around the same, it's sort of same sort of ballpark. And it's only about 17 pounds, which is quite good. That's without a header, so you have to buy the header separately and solder that in on yourself. That's part of the fun, right? The next one worth considering buying new is the Pi 4 Model B. So the Model A is the first model, and they haven't really made any. Well, they make a few A's. There's a 3B plus, A plus, which is a good little machine. The only difference is the form factor, sort of like a square. So this is also worth buying. So it's 75 pounds. Very solid piece of kit. But if you're going to buy this, then you may as well go for the 5, or sorry, the 5 was talking in a minute. So the compute module, the idea of this one is that if you're building custom hardware, you may want to just buy the compute module itself and build your hardware around that, rather than dealing with the form factor and the GPIO pins and everything like that the Raspberry Pi normally has. You can sort of build your own built board around it. And that's exactly what Raspberry Pi has done with the Pi 400. So that has a compute module in it. And the great thing about this is it's got everything self-contained in there. So you just buy what looks like a keyboard and all that connects to your TV screen or your output. And you can plug your mouse in and your network cable and stuff like that. So this was really sort of going back to the old days of the BBC Micro. So if you see Eben on a talk, he often says, well, this is sort of what he was looking for, something that you just plug the thing in and play with it. It's sort of nostalgic. So also a very solid Pi to buy. Do lots of things with it. And then there's a Pi 5. So there's significant improvements for the architecture in this one. It's 2-3 times faster than a Pi 4. It's got PCI Express, better camera support, better networking, etc. So if you're going to buy a new one and you're going to spend that kind of money, I wouldn't go for a 4 unless you go for like a 4 with a 1 gigabyte, and that's quite a bit cheaper. But if you're going to go for the 4 gigabyte or 8 gigabyte model, then you're much better off getting the Pi 5, really. The Pi Pico W is actually a really, really good choice if you're first starting out. So, but it's a microcontroller. So in other words, it doesn't have a full operating system, doesn't have Linux there, but it's super cheap and they're super fun to play with, and it's really easy to get started. So if you're looking at what Pi to buy, and this is how I think about it. So if you've got, you only want to spend £7, and the plus is for all the other accessories you're going to need. So everyone's got a few USB chargers at home, so that doesn't really count in, or you can even just plug it straight into your PC. So really, you only need an extra pound or so to buy a header for it. So very, very fast and easy to get going. So it doesn't have Linux. It's very good for simple projects, very good for battery power. You can't really run you can't run a modern GUI on it. It doesn't have a Linux, doesn't have an operating system, but you can buy little displays that sort of have buttons and things like that, and you can do some simple graphics with it. Advanced projects, you can't really do much with that. You can use it with a Pi, obviously, to do an advanced project. And you can't use it a desktop. As I said, there's no Linux GUI or anything like that. The Pi 0W, which is the original 0W, it's only a little bit cheaper than the 0W2, and the power is much less. So you can still buy these. It's about 13 pounds. And the plus there is because you'll need a micro SD card. You'll need probably going to need a case for it. You're going to need a power supply, and some headers and things like that. So once you buy all that stuff, you buy a kit with all that stuff in it, you're looking at about 42 pounds from Pimoroni. Yes, I think they do, yeah. I haven't seen one. I haven't looked for one. Yeah, it's only an extra couple quid to get the W version. Yeah, that's a good point. It's a good point. So, has anyone used Pico before? Has everyone used Picos before? No? Yeah, they're really, really great. I think it'd be really good for, especially combining with a Pi. I know a lot of people do, Arduino with a Pi for a project. That's a really good combination. So 0W, yeah, so good for Linux, simple project. When I say simple project, it means you can do some fairly good things with them. Not just flashing LEDs, but something quite a bit more substantial than that. So battery power is fine. It's a little bit too slow for a GUI, but the Pi 0W2, only a few more pounds, can do all those things. You can get a decent GUI out of it. You do an advanced project, if you're pushed to do it, be a little bit more difficult. You could use it on a desktop, but it's not very snappy. It's a bit painful. Then the Pi 4, yeah, around 36 pounds. So if you're looking for a lower end, and nothing wrong with the lower end, especially if you're planning to use it for something that's embedded and you just leave it there forever, which I have a lot of around my house. If you're just getting something and you're just gonna, put it into a water softener monitor or whatever, run your furnace or something like that, you really wouldn't want to buy a Pi 5 or even a Pi 4 maybe. You also go with a Pi 0W2 or W even. So the Pi 4, absolutely Linux. You probably don't want to use it for a simple project, a bit of a waste. Battery power, for the Pi 4, battery power is not going to be great. Great for a GUI project. Advanced project is fine. Desktop, probably get away with it, but you may as well just get a Pi 5 for that. So then the 5 obviously is a bit more money because it's only sold in the 4 and 8 gigabyte at the moment. So yeah, again, probably wouldn't want to use it for simple project, bit of a waste. Hard on battery power, although at the same load as a Pi 4, it actually uses less power. So just because the architecture is a lot better, and of course, you could use it quite well for a desktop. Works quite well. So what other bits should you buy? So I've got experience with all these sorts of things almost. So this touchscreen is really good. So I don't know if anyone else uses the touchscreen. 70 pounds. It's very solid. I've never had any problems with it really. I've had a little bit of, or actually I've had a problem with configuration issue. But for 70 pounds, it just clicks away nicely forever. So I brought one today. You guys can have a look at. That's my scale project. I'll talk a little bit about. There's these hyperpixel displays, and these ones. So both the touchscreen and the hyperpixel display both show the whole GUI. So it's like you're using the Raspberry Pi with a monitor connected. But the hyperpixel display is so tiny, you can't really read anything. So I don't really see the point in that. You'll probably end up just creating a GUI to sit on top of that. And it's quite small. I didn't bring mine, but it's just the size of the Pi. So it's not so useful for what I usually do. Sorry? Yeah, that's a good point. It blocks all your GPIOs. So when you're looking for a display, you have to look at, what GPIOs do I still have access to? A lot of them have I2C on the back, so you can still get access to I2C, which is to get sensors and things like that. But yeah, I was quite disappointed when I bought one. Because really, that's kind of my whole point is in GPIO access. If you can't get that, then so it's just sitting there. I should have brought it in and gave it away to somebody. Oh, okay. Okay. Okay, nice. Yeah, okay. That's a good idea. Right. Yeah, so I don't know if people heard that, but Mike Turner was just saying that you can actually hack it a bit and get access to some of the GPIOs that aren't actually used by Hyperpixel. So that definitely worth trying. I'll definitely try that before I get my Hyperpixel. Then you can also get these tiny little OLED displays. So this one is 0.91 inch, which is a couple centimeters. So that's quite good. So these are the prices off Pimeroni or Pimeroni, whatever they call it. So $7.50, you can get a lot cheaper from someplace like Amazon if you're desperate to save a few pounds. But it's, they're good. They give you a crisp display. They don't, just fairly basic, but very quick to do. But then you have to build all the GUI components yourself, and you're writing images to the screen and things like that. So it's a bit more fiddly. Same thing with the e-ink displays. So they're really good. You can get them for a little bit cheaper than that, but not much. They can give you a lot of pixels to display, and they do have multicolor ones now. So this is just a 2-color one. I've got a 3-color one that has red. The issue with these is that they're very, very slow to update. So when you write to the screen, it can take, I have a clock at home, and it gets about 30 seconds in, it's still updating the screen. So it's not great, but I do like the look of them. So I do use a few of them, but you do have to keep that in mind. One of our guys did a presentation on putting his CCTV to some Kindles. So that was a quirky project, very nerdy. So yeah, he only gets like one screen a second or 2 screens a second or something like that. So that's quite interesting. Yeah, power use is very low. I guess the other thing to consider is that if you remove the power entirely, it stays like that. So these are used a lot for badges and stuff like that at conferences and things. So yeah, they're good devices, but make sure you know what you're trying to build before you buy one. Various cameras. So Raspberry Pi is big on cameras. So we've got camera module 3, 3 Noir. So that's for night cameras or for night shots. I've got one of these night vision cameras. I guess I don't know if it's much better than the Raspberry Pi original, but it does work fine. It was I just had using it outside, so I cut through some plastic in a junction box and had to put hot glue all over it and burn my fingers horribly. But it works. It's quite nice. It sort of captures foxes and things like that in the garden. It's good fun. And then we've got the Raspberry Pi high quality camera. If you want a proper camera, then that's what you would buy. So 57 pounds. Apparently very good. I've never used one before, but you have to keep in mind you also have to buy a lens. So if you buy the lens as well, you're looking at what's that? That's 60, 90 pounds by the time you got the lens. I've got a global shutter camera, but I haven't bought a lens yet. I need to find a use for it as well. So the global shutter is that it takes the whole picture in one frame. So the high quality camera sort of does a scan, a very quick scan, But if you're trying to capture a fast moving object, you need a global shutter camera. So these are very expensive if you buy one for professional use, global shutter camera, but these ones are quite reasonable. But again, you need to buy the lens, which I didn't realize, but now I know. So very basic projects, if you're just getting started, just light up an LED. A little bit more complicated is you can put in some MOSFETs, and you can drive these cheap LED strips, 12 volt or 24 volt LED strips they're very cheap. Might be a couple pounds per meter, that sort of thing. And they have RGB. But these are not neopixels. These are just the most simplest strips you can buy. In general, you're probably better off just going for neopixel, but these are also useful. Especially if you've got something already, like in your house, for example, somebody may have installed or you've installed this style, then you can at least use it there. So we just need 3 MOSFETs to drive it. So we can just look up online how to do that. That's a good starting project, or like a second project after you do the basic one of just lighting the LED. And then NeoPixels is the next grade up. So the way a NeoPixel works is that each LED, so for on this strip, for example, you send the RGB code for each light that you want. So you have 8 bits for red, green, and blue, and you send one 3 byte pair, three bytes for every NeoPixel on your strip. So if you've got 200 NeoPixels, you send 200 times 3 bytes. And that can be any color that you want. So often you just, you sort of, it's really fun to play with, really. So you can do things like, when I first started, I was just turning a couple pixels white, and sort of move them along the strip just to drive the cats crazy. So cats would run after the strip, after the lights, and then sort of bounce back and things like that. So that's good fun. Relatively easy to do on a Pi. You do have to download the light library. So here on so we can't quite see on the screen here because this is in the way. There's the Adafruit. Oh no, yeah, the Adafruit NeoPixel Uber Guide, which is really good. Just walks you through all this, talks about power requirements, et cetera, et cetera. And there's all these different form factors. So that's what a NeoPixel looks like there. So you've got a little chip, and then you've got 3 different LEDs, and when they're all on, they can see different colors. So you can see it in sort of this matrix size. This unicorn hat HD, which I've got one here today, and these fairy light strands as well. So those are all good fun to play with. So this is something you might have on your Christmas tree, and you can do various patterns with that. Various sensors. So one of the ones I played around originally was with this MPU 6050. So this is a 6 degree of freedom accelerometer. So again, I brought one today. I can show people. But essentially, it measures the acceleration in 3 dimensions. So you got X, Y, and Z coming out of the chip. And then it also does yaw, pitch, and roll, so the rotational angles as well. And it does have a simple IMU. I guess I've never really used the IMU properly. So that's sort of determining your location based on all the calculations, all the sensors. I don't know how accurate it is, but it's something worth playing with. So this is what I'll go through our projects, what I use each one for. Building a weather station is quite a bit of fun. I haven't done the weather station before, so you can buy these hats and all the different accessories you would need to do that. Or you could buy each individual part separately, which would be quite fun. And then you've got CO2 sensors here, things like that, and time of flight sensor, which is determining distance. So it sends out a light, bounces off, and determines how long it takes for the light to get back. So that will, those work quite well. I went through a project with that. And then also these ones here is, so this is for hooking up to a scale, a bathroom scale, or kitchen scale. You may have noticed the kitchen scale over there, so I'll walk people through that later. But essentially, there's 4 strain gauges in each of the corners, and you hook it up in a Wheatstone bridge. Then then you measure the voltages coming into HX711, and then you connect that to the analog digital converter. Or so HX711 is a analog digital converter. Connect that to your Pi, and that gives you the weight after you've zeroed it out, after calibrated it. So those work really well and they're a lot of fun. So that's definitely something worth doing. And then you've got various actuators. So you've got servo motors that run a certain degrees. So they're often 180 degrees. So they sweep from pointing this direction to pointing that direction. You can get some that are 270 degrees, which do a 270-degree arc. And you got some continuous servers that just turn round and round. So I don't know why that'd be a servo, but those as well. You've got stepper motors, which you step them a little bit by bit. So most of them have 200 steps. So 360 degrees by 200, so at 1.6 or whatever degrees per step. So 1.8. So you've got just run that by these little boards here. You just connect your Pi to it. It's fairly straightforward to do. And then you've got DC motors, which you connect and just run them with PWM. So that controls the speed. So you pulse width modulation. And again, you can look up online how to do that. So obviously there's all sorts of other things you could have. You could have solenoids and things like that, which are relatively simple, but these are some of the main ones. So if you're building a robot, for example, you might have several of these actuators in a single robot. Then there's all sorts of other interfaces that you may use. So here we've got some Telegram. So this is, so Telegram is, it's very much like WhatsApp. You haven't used it before. So this I use for setting messages to with my monitoring my water softener. So it just sends me every morning a message with how much salt it's used. So it's fairly simple to connect to. I don't know if you can do the same thing with WhatsApp, but Telegram is sort of built for that. So you can use something called BotFollow to create your own bot, and it's relatively simple to interface to it. Bluetooth, you can hook up Bluetooth speakers to a Pi. So it's very useful if you've got, yes, we'll talk about what I did with Bluetooth in a minute. Then you've also got things like Grafana and other tools that sort of run visualization tools on your desktop, on your Pi, and then connect to them from a laptop or a computer. So this is one of my main projects that I brought today. So this is called a Pi Fighter, and the idea is that, so you can notice the Unicorn Hat HD here. You can notice the accelerometer here that I was talking about, and that is connected to the Pi. And the way you play the game is you log on and you select a Star Wars character you want to fight, you want to spar with. And then you, when the fight starts, you punch the punching bag, and this imaginary character is punching you back. So I can show you that after the talk. So you can see here, for example, on the left-hand side here is my health, my attack next to it. And then it's this big, whoops, sorry. The big green bar there is my opponent's attack, and the small pink area there is my opponent's health. So it's like a video game. So you're punching the punching bag, your opponent's punching you, and as if you win the fight, you get half your health points back, or get half the health points that your opponent had added onto yours, And as time goes on, you get stronger and stronger, and you can fight more difficult components. So obviously that's me punching the bag. That's my son doing the same. So yeah, it's just it was in the Magpie magazine at one point, a long time ago. And you can tell it's been a long time ago because when I looked at the code, I thought, oh my God, it was a bit horrific. This is another one that was in Magpie 120. So again, this is using NeoPixels. So we use these NeoPixel strips that I bought off Amazon, using an e-paper display there just to show the delays on the tube. And this is running, this is a Pi 0W2, I think. It might actually be a W2 running 300 NeoPixels across, I think it's 4 different strips. And I had to do some multiplex because they're a bit of a weird NeoPixel. But yeah, so that worked quite well. So this Pi 0W2 is connecting to the London Underground or the TfL website and getting the status of all the lines, and it's flashing the LEDs depending on the service. So it is flashing quickly. It's minor delays. It's flashing off for a long time and then on, and it's major delays, etc. And this is the one that also connects to Bluetooth speaker. So if you send this message here, 1629 circle line, minor delays due to damaged cables in the parking area, to Google, it will send back an MP3 to you, and you can play an MP3 on your Bluetooth speaker. And it sounds very realistic. It sounds like you're in the tube station and somebody's talking to you. Yeah, so that wasn't a very good day for us. I work on one of the projects, and yeah, some of our cables started on fire, so it was a bit of a horrific day.
What is the 0.5 answer? You can make that out.
Sorry?
The 0.5 that's it's got a text box in the middle of the left screen.
Oh, this one.
Just above the banana.
Oh, yes, it says banana scale.
Oh, okay. Sorry, there's the wiring somewhere.
No, that's just for scale. Oh, all the internet. Sorry? Yeah. Yeah, it's all the internet being banana for scale. Yeah, so a good little project, took me forever, mostly for the mechanical bits, sort of. Well, there's lots of bits I need to sort out. Like getting the multiplexing working was a pain. Drilling 300 holes was a pain. Running each LED to a different hole and hot gluing it in. By then I learned to wear gloves, so I didn't burn myself this time. But yeah, it was a lot of work. So yeah, if I have often out in the background when I'm doing a meeting, and a lot of my colleagues want me to build them one. I'm drilling 300 holes. We only do that much, mate. Yeah, it's just the NeoPixels. Yeah, you've got to map them out. Yes. Yeah, they're NeoPixels, so you do have to. I did have to sort out because I was just zigzagging them around, that I had to like figure out what I'd done. So pixel 55 is on this line, that's the station, and so on. I did try to like plot individual trains at different stations, but it was real pain. It didn't really look good. Yeah. Yeah. Yeah, it can be difficult. So just some people in the room are commenting about the NeoPixels, and if you run them around everywhere, then you have to sort of map them to different physical locations. So it can be a bit of a pain. This was a massive pain, and at one point it actually cut through the string, and I couldn't get it working again. And, literally like an hour after it was all working, it stopped working. Oh my God, what happened? So luckily I was able to recover it. But yeah, imagine spending a few weekends doing that. Um, Yeah, so if I was gonna do this, if I was gonna do this again, um, yeah, yeah, I guess it's different in terms of technology. I'd make sure I didn't buy the ones that are absolute memory ones. So the ones I end up with have are not typical NeoPixels. So they actually have a memory for each NeoPixel. So this is pixel 1, pixel 2, pixel 3, pixel 4. So if you join them together, normal NeoPixels, you can join them together. So if you've got 200 NeoPixels, got two strands of 200 NeoPixels, you join them together, and the 201st NeoPixel knows it's 201, or doesn't have to care. It knows what to do. With these ones, when I joined them together, I had 100 strings of 100. So if I let pixel 1, 2 would actually light up. If I let up 50, then 50 and 150 would light up. And it's like, ugh. So it took me forever to figure out they actually had addresses, and I had to multiplex them. So I'm sort of switching to one, switch to the next one, switch to the next one. So it's just a real pain. So that's one thing I would change. But these fairy lights were very good because they have a good diffusion. It's like some plastic in there that diffuses them. And then when that's behind the piece of paper that the map is, then that works really well, actually. And it's enough power that I can set the power to a reasonable level and see it quite well. And it works quite good in the dark as well. So it's really worked quite well. Guess, yeah, I would probably do a lot better job on like running the strands and how I run them and stuff like that. Probably get a little bit more prepared. Yeah, just be a bit more organized, really. Yes, absolutely. It's mandatory. Always use a banana for scale. Yes, I forgot my banana in this one. Um, yeah, so this is my kitchen scale project. And this is one that I started after I realized I was too heavy. I need to lose some weight. So the idea is that it weighs my food and figures out the calories. So in this case, you put the bowl down, you zero out the scale, you put the pasta on, you say, okay, I'm having pasta, white pasta, measures that number, how many grams it is, calculates or multiplies by the calories per 100 grams, and then gives you a number of calories. And then then you put the tuna on. So it's tuna. So it's like, I don't know, 130 grams, 140 grams. And then it calculates tuna is 160 calories per 100 grams or whatever it is, multiplied to 140 grams equals number of calories. And then it plots it all and adds it onto your day, and then plots that against how many calories I consume from Google Fit. And then also tracks my weight. So I also had a bathroom scale that I hacked, and so I can stand on the scale, it sends it to this, and I can track my weight against that. So yes, I lost some weight. So it worked. So this pie may have extended my life significantly. Not sure many people can say that. Servos. So this is just a silly project. So this project here is obviously telling me the time. It's telling me the status of all the tube lines, and it's spelling out the time with semaphores. If you see the guys on ships doing this, sort of spelling stuff out, that's the same idea. So it's spelling out 2130 in semaphores. I think it says 21H30M or 29M or 30M. So you can see how slow the e-paper is from that as well. So it's probably slowed down a little bit even more because of the lag. Again, using servos here. So this is a sun tracker. So you put in your latitude and longitude, and it tracks where the sun is throughout the day. So it's sort of rotating around and rotating in the yaw and pitch, so you can see where the sun is. And the original idea for that was for a solar oven. So if you have a solar oven that sort of takes the sun rays to cook your food, really want it pointing at the sun all the time. So that was the idea, but never really went further than that. So this is the time of flight. So I mentioned the time of flight is quite a good little sensor. Sorry, just go back for a second. So yeah, those last two projects, both, sorry. Yeah. So this, the one on the left here is using the 3A plus. And this one here is just a Pi 0W. So that's running, running the servos quite capably. So time of flight, this is my water softener, which isn't very healthy at the minute. There's some problem with it, but it's still getting its salt measured correctly. So this is the time of flight. So that gives you an idea of how big it is. Tiny little thing about that. Thinking about 3 or 4 pounds each. So I squared C, you just download the library, connect the library to the time of flight sensor, and it gives you the distance from the sensor to whatever you're measuring. In this case, it's measuring the how much salt is in the salt hopper here. So yeah, and then neopixels here are just showing how much is left as a visual indication. And then, as I mentioned, I also get a message from Telegram. And that's my last slide. Are there any questions or any of that or comments on that? Does anyone have any projects they want to share of their own?